Hello, class. I'm going to finish up that 3.1 section for your statistics course. So we're at the bottom of page 63, and they're asking for the measures of central tendency, the mid-range. So the mid-range is the average of the lowest and the highest values in a data set. So we have MR, which is the abbreviation for mid-range. And I'm going to put a set of parentheses here in the numerator. Lowest value plus highest value divided by 2. And the parentheses are required, they're needed. Otherwise, you can have an error when you type that in onto the calculator. So it says bank failures. The number of bank failures for a recent 5-year period is shown. Find the mid-range. So we would have MR is equal to the lowest data value, which looks like it's 3, plus the highest data value, which is 157. Close parenthesis divided by 2. Yeah, so it looks like that's 160, right? 157 plus 3 is 160 divided by 2, so that should be 80. Okay. And so if I type this in, parenthesis 157 plus 3 divided by 2. And that's okay. I put in 157 first, and that's okay. Divided by 2 is equal to 80. Okay. Yeah. So the only thing is that I didn't type is the formula, but you have it right here. Usually on the test, I'll say I want the symbol, the formula, the substitutions, and then the answer, and then if needed, the units, if you have any kind of units. Um, and so having to do with some kind of a length or measurement. Okay. So in this case, this is fine, and then I would just include the formula. Let me just do. Okay, and you got that right there. Okay. Okay, and let me look at what's on page 164. Yeah, so this is just more practice. So I'll let you do these on your own. You're finding the mean, and it's not group data. The median, the mode, the mid-range. Yeah, so that's for extra practice there. So I'll let y'all do that on your own. Then when I do put the answers up and scan them, you can go back and check that. Okay, and 65. So again, more practice defining the mean and the modal class. Yeah, so that's extra practice. Again, this is to the tenths place. So I wish I had varied it. It seems like all those 4 examples are all the tenths place. I should have varied it because your answer will be the same decimal place values as your class boundaries. So the answer would be in the tenths then. Okay. Okay, here's something new down here. Measures of central tendency, a weighted mean. Okay, we haven't done a weighted mean yet. Find the weighted mean of a variable by multiplying each value by its corresponding weight and then dividing the sum of the products by the sum of the weights. Okay, so there's that x bar again, which we've seen before for the mean. Okay, and then notice how they have the subscripts w sub 1 times x sub 1 plus w sub 2 times x sub 2 plus on into the last one, w sub n times x sub n divided by this amount, w1 plus w sub 2 plus all the way to w sub 3. Okay, and then this is the shorter formula, the summation of all your w's times your x's divided by the summation of w. Okay, all right. So I have a note here that, again, this stands for sigma. You're wondering what that is. That stands for sigma. It's one of the Greek letters of the alphabet, and what it is it's a summation Okay, so I have here grade point average. A student receives the following grades. Find the corresponding grade point average. And I have a note here that these x's here, these x's, the x variable represents our data for rounding purposes. Okay. So you can see, let's see, for us, here's the, I was looking for the X, so you just kind of capitalize it. So it's right here, this X. Here, the credits are called W, the grade is called X. So the X arrow represents our data for rounding purposes. Okay, so you'll notice that your X is listed as counting numbers. So I'll put X counting numbers. So 4, 2, 3, 1. Counting numbers. And so because of that, your answer, remember, has to be one decimal place beyond how your data is given. And so we're going to round this off to the nearest tens. So I'm going to put that here. Let's see. I'm going to round the mean. So weighted mean. So round the weighted mean to the nearest tenths. And so that's one decimal place beyond how data is presented. Okay, and for us that was X. Okay. And then what we're going to do is I'm going to add another column over here, and I'm going to add W times X, W times X. So this is going to be 3 times 4, which is 12. Okay. And this next one's going to be 3 times 2, which is 6. And this is going to be 4 times 3, which is 12. And 2 times 1, which is 2. And then when I do my total summation of the W times X, and when we add all these up, this gives us a total of 32. Okay. I'm also going to add these up, summation of my W's. When I add all these up, that gives me summation of my W's is equal to 12. Okay, so then when I start working up my problem, I have mean X bar is equal to the formula. I'm going to use a shorter one. Summation of W times X divided by summation of W. So summation of W times X, so that was this one. I added everything up. That was 32 divided by summation of W's. I added everything up. That's 12. And then on my calculator, when I do 32 divided by 12, gives me 2 with a lot of repeating sixes. 1, 2, 3, 4, 5, 6, 7, 8 of them. And then I'm gonna round to nearest tenths. This is the tenths place right here. This one's tenths. Look at the neighbor to the right. Is that 5 or more? Yes. So add 1 to that. So it's about 2.7. Okay. All right. And then there's really nothing to label. You know, there's no units on that, so that's fine. That's called a weighted mean. So we had English, psychology, biology, and PE. And those were the grade points. They were worth A's are worth 4, B's are worth 3, C's are worth 2, D's are worth 1. And if an F is earned, those are worth 0 grade points. Okay. Okay, now I do have another weighted mean, one from your handout. Um, you know, the extra handout that I was talking about. At least I could find that. There is also one that you could do on your own. This is also a weighted mean. But the one I have, I'm going to do, let's see, I can find that. Yeah, this page also has a weighted mean here. See how this one's similar. This one already has the chart filled out. So on the other one, you could build the chart on the other one, but this one already has a chart built out. And also because it's got percentages. So that's why I'm interested in doing this one, because it's got percentages. The one at the top of page 66 doesn't have percentages. So it's a little too similar to the previous one we just did. So that's why I want to show you this one. And it looks like this one looks like this one came from your ebook. So you have a number 27. So it looks like that was a problem probably from your ebook. So an instructor grades exams 20%. Okay, so weight here. So show that on here. And usually with percents, when you work with them on paper, you usually have to change them to decimals. I have a note here that you would want to move your decimal 2 places to the left to change a percent into, and this got cut off, into a decimal. So you move your decimal places 2 places to the left. So if you don't see the decimal, it's understood to be in the back. And then when you move it 2 places to the left, that's why I have here like 0.20, for example, which basically is just basically it's 0.2 then, right? And then 30% for the final exam. So I move it over 2 places. So we're looking at 0.3. And you can be formal. You want to put the 0 in, you can. Okay. Let's see. Well, I think that was a term paper. So an instructor grades exams at 20%. Oh, the term paper, sorry. The term paper is 30%. And then the final was 50%. A student had grades of 83, 72, and 90 respectively. So that means like in that order. So first they talked about exams. So that would be your 83. And then they talked about the term papers. That would be the 72. And then the 90 would be the final. And they want you to find the student's final average. And you're supposed to use a weighted mean. Okay. Okay. So here, summation of W, when I add these up, the 20 and 30 and 50, that's 100%. And then you move your decimal over 2 places to the left, and that should just give you 1. And also if you add, 0.5, 0.3, and 0.2, that should give you a 1.0. It gives you that as well. And then when you multiply W times X, W is 83 times X, which should be 0.2. So if I use my calculator for that, 83 times 0.2, 16.6. And on a test, you're only required to show this multiplication for this first part. And like if you have a percentage for this first part, then after you've demonstrated that, then the others you can just multiply. Like here you do 72 times 0.3, then write that value down. And then 90 times 0.5, then write that down, okay? Okay, so then when I add those up, 45 plus 21.6, 16.6, that gives me 83.2. Okay, I'm gonna put little parentheses here also. Summation of that product, that's a product there. Okay, and then you see when we're showing the formula, like if this were a test problem, your teacher wants a symbol. So this is also this. So for mean, it will always use X bar. This is a weighted mean. And before we did a mean for group frequency data, and then we had just a mean just for sample data, right? So, and so we have the same symbol. And then here's the formula for this one. So the formula is a little bit different, right? Weighted mean divided by that. And then we have 83.2 divided by, in this case, 1, which is just 83.2. Okay, now the thing about the rounding, you're supposed to round one decimal place beyond how your data is given. So remember, X is considered our data. So our data data, which is x, is given as, see, these are counting numbers. So that means you want to round the mean to the tenths place, one decimal place beyond how the data is given. So in this case, this is already in the tenths place. Okay, so we're already good on that. Okay, on the bottom, in the past, the homework has had a problem similar to something like this in the past, and we have this new enhanced version, so this may not be there. I'm not sure. I have to look. But in the past, we've always had a problem related to this on homework. Well, the student's final average is 83.2. Okay, so it says here that if the mean of 7 values is 43, so you've added them all up and they're divided by 7 and it gives you 43. They want you to actually find the sum of the values. So the idea of your mean formula is you go back to the very first formula that we had. Summation of x is equal to summation of x divided by n. That was one of our first formulas that we had back when we started 3.1. I think I can show you that. Let me see if I have that here. Yes, that's this one here. When we first started 3.1, that was back on page 58. Okay, so do we know any of these values? This one or this one or this one? So I have a note here to let x bar equal 43 because it says the mean is 43. So that means here the mean is 43. And let n equal 7, right? There was 7 of them. And we're trying to find, so we have this and we have this. So we're trying to find the sum, see, the sum of the values, summation. So here what I've done is I have multiplied like an x, cross multiplied x times n is equal to, that cross multiply, there's an imaginary 1 right there. So then that gives me x times n right here is equal to summation of x. So that, and so we have x times n for s. Let's see, what was x? The mean x bar was 43. So this is substituted. We're going to sub. So x bar is 43. Short sub for substitute times n, which was 7. And that's supposed to equal the summation of x. So let's see what 43 times 7 is. 43 times 7 is 301. Yeah. So the answer is just 301. That's the answer. So this part, I can take this off. I don't really need this in here. Yeah, but that's it says find the sum of the values. So this is the sum of the values. Okay. All right. Okay, now let's see. Okay, let's go back to 66. Okay, so also in the past, they have asked on the homework some questions about these definitions or these properties, and I have see I have from the ebook number 29 and from the ebook number 30, and it says for these situations, state which measure of central tendency should be used, and they talk about the mean, the median, the mode, but they didn't include all of them. They didn't include the mid-range, right? MR is the mid-range. Okay. And that's okay. They didn't use all of them. All right. So keep that in mind. And so the first one we're going to go over is the mean. If you look at this properties of the mean, so it's found by using all the data values, right? Because you have to, for the most part, is you're adding them up, dividing by how many you have. It varies less than the median and it varies less than the mode. So that's a good thing to be aware of. It's used in computing other statistics, like, for example, they say such as the variance, which we'll cover in the next section, 3.2 variance. This is kind of how your data is spread out. It's unique. Usually it's not one of the data values. Yeah, so usually when you get an answer, it's not going to be a data value answer. Cannot be used with open-ended classes. Okay, yes, that's true. And let's see if I had an example. I did have an example of an open-ended, and this is, let me have, I have a note here. This is because cannot be used with open. This is because this creates problems in the calculations. And it's affected by extremely high or low values that they call outliers. Okay, and I wanted to show you an example of the open-ended. Let me show you an example of that. So let's say I have weight. Let's say this is in pounds. And then I have number of persons. And let's say I start off with below something 210. Or if I have all the way down to 130 to above, something above that. Okay, let's say I have a 6 here and a 12 here. Okay. And we say that this creates problems in calculations because it says either no lower class limit or no upper class limit exists. Okay, so either in this example, the way it's given, either no lower class limit or no upper. So this is lower class limit. This is upper class limit, right? So these are all the lowers. These are all the uppers. So that would be an example of an open-ended when you have no lower class limit or you have no upper class limit existing. So it cannot be used with open-ended classes. Okay, just keep that in mind. Okay, let's see. Okay, so I'm going to show you, I'm going to point out in this example, this page, if you printed this page out, which ones would be an example for the mean. So let's see, 29, A through F. Okay, so the mean. So the first one on 29 would be E. Look at E. Further statistical computations will be needed. Be a mean. And that's because if you look here, it says like it's used in computing other statistics, and it gave us one example, which would be the variance, which we'll see in section 3.2. So further statistical computations will be needed. It's related. And on 30, the mean, it would be number B. Look at 30B. So it says the average number of children per family in the in the Plaza Heights complex is 1.8. Okay, so the average number, you add them up and divide by how many children are there. That would be an example of the mean. Okay. And then F, the average age of college professors is 42.3 years. That'd also be mean. You add them up, divide by how many you have to find that. Okay. Now, the reason why D is not there, D also has the word average, but then it says once a week. So remember how we had that problem where we were taking the data and the number of occurrences, and that was related, I believe, to the mode, right? That's why I'm not going to highlight D as a mean. Okay, next we're looking at median. Median gives the midpoint. It's used when it is necessary to find out whether the data values fall in the upper half or the lower half of the distribution. Can be used for an open-ended distribution, and the median is affected less than the mean by extremely high or extremely low values. Okay, so when I look at the median, 29 and 30, so for 29, median would be B, the distribution is open-ended. Also C, there is an extreme value in the data set. And then F, the values are to be divided into two approximately equal groups, one group containing the larger values and one group the smaller values. So those are all tied to what I was reading. And on 30, it would be A, one half of the factory workers make more than $5.37 per hour, and one half make less than $5.30 per hour. Okay, and then that would be all for the median. Okay. Let's see. Okay, then we have mode gives the midpoint. It's used when it is necessary to find out whether the data values fall into the upper half or the lower half. That's the median. Reading the median again, sorry. Mode, here we go, mode. Sorry. Used when the most typical case is desired. Easiest average to compute, can be used with nominal data, not always unique or may not exist. Okay, properties of mode. So let me go back to your problems here, see what's left here. So that would be A, the most typical case is desired. And then D, the data are categorical. Okay. Okay, on the next page, C is the mode most people prefer a red convertible over any other color. So that's mode. Also, E, the most common fear today is fear of speaking in polls. That's mode. So I think we got all of them answered already, right? Yes, okay, good. And even though they have mid-range here, they didn't put any examples on 30 or 29 there. Mid-range, properties of mid-range, easy to compute, gives the midpoint, affected by extremely high or low data values. Okay. Excuse me. Let's see, what else do we have? I think there's one more page now, and then one more page, and then one more page that's we're going to make it related to this example here. Distributions. Okay. So these pictures should look a little familiar here. Okay, so this is a positively skewed. We also call it right. Yeah, it says right skewed, positively or right skewed. And notice here how I am going to write something down this time. I am going to write how the data tends to taper off. See, here's your peak. And your data does tend to taper off more so on the right side. Yeah, so we have here that the data tends to taper off more so on the right side of the peak. Whereas, let's see this one. So you can pause that if you haven't written that down. Okay, this one is it's more like symmetric, right? This is more symmetric. Excuse me. Then this one, here's your peak. So this one, the data tapers off on the left-hand side. And it doesn't have the description on this one, but this should show negatively skewed. Or left skewed. Okay. Okay. And then Let me see if I have any other notes. We do have to talk about the M's, the three M's. That's how it's related to this section. Let me just see if I had any other notes here. Okay. Now, so let me see. Maybe go back and read this and. Okay, so it says that in a positively skewed or right skewed distribution, the majority of the data values fall to the left of the mean and cluster at the lower end of the distribution. The tail is to the right also. The mean is to the right of the median. So it's saying, let me highlight that. The mean is to the right of the median. The mean is to the right of the median. And the mode is to the left of the median. For example, if an instructor gave an examination and most of the students did poorly, their scores would tend to cluster on the left side of the distribution. A few high scores would constitute the tail of the distribution, which would be on the right hand side. Okay, so 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 if you're trying to determine the data's distribution, you can just look at the three M's. What's the value of the mode? What's the value of the median? What's the value of the mean? And if they're in order in size, if they're in order in size, where the mode is the smallest and the mean is the biggest, then that would guarantee that your data is positively skewed or right skewed just by knowing your three M's, the mode, median, and mean. Whereas they say that if the mode, median, and mean were all the same, that would mean that you have a symmetric distribution. In a symmetric distribution, the data values are evenly distributed on both sides of the mean. When the distribution is unimodal, the mean, median, and mode are the same and are at the center of the distribution. Yeah, so they're the same value, because that's kind of unique there. When the majority of the data values fall to the right of the mean and cluster at the upper end of the distribution with the tail to the left, the distribution is said to be negatively skewed or left skewed. Also, the mean is to the left of the median and the mode is to the right of the median. So these values here, see, 3 M's. An example, a negatively skewed distribution results if the majority of students score very high on instructor's examination. These scores will tend to cluster to the right of the distribution. Okay. Okay. So let me see. So we're going to do one last problem, which is from the ebook, from that page here. Natural gas drilling sites. So the number of natural gas drilling sites in Pennsylvania counties with drilling operations is listed below. Find the mean, find the median, find the mode, and the mid-range for the data, and then discuss the differences in these measures of central tendency, which best describes the center of the data. Yeah, so we're going to find these M's, and then we're gonna look at the data distributions. What we're going to do is look at the data's distribution, see the three values of the M's and then see if we can decide if it's left skewed, right skewed, or symmetric just from the values of the m's, okay? Okay, so what we're going to do is enter the data, enter all this data, and this is small, this is 695. Can you see that 695? We're going to enter your data. And L1. So let's do that for starters. So turn the thing on. Go to stat. Edit, one edit. Okay. Okay, so go to top, clear. Okay, then let's go ahead and put all this data in. You can either go up and down and put it in, or you can go across. Okay, and let me just. Sometimes you can also use a ruler, that helps. Excuse me, sorry. Excuse me. That's a 695. This is a 695. Okay, so these were the number of natural gas drilling sites. This is in Pennsylvania. Counties with drilling operations is listed below. Okay. Okay, so now we're gonna find the let's see, which one does it matter which one we find first? I don't think it matters which one we find first, but we started off with the mean, right, when we started 3.1. So if you want to go in this order also, they are saying to find the mean first. Okay, so you start in that order. So then we would do stat edit, right? So stat calculate one. So stat calculate one variable stats, enter, and you leave your list is L1 and leave this vacant. Okay, so there's our x, see that x bar, and there's your summation x 4,984, and you're dividing it, see, by 37. Did they say there was 37? Sometimes they'll tell you here. Now you have to count and make sure that you didn't leave anybody off. 3, 4, 5, 6, 7, 8, 9, 10, 20, 30. Yep, 37. Okay, so that gives us this. Okay, now as far as rounding, see how data is given as counting numbers, right? All these are counting numbers. So I would go ahead and round the mean to the tenths place, 1 decimal place beyond how that data is given. And if I round to the tenths place, look at the number to the right. Is that 5 or more? No. So don't increase this. So it just looks like it's 134.7. Okay. That's for your mean. Okay, the other thing they want us to find is the median. Oh, I remember. Sorry, I forgot. Excuse me. Remember, we're supposed to use this symbol. We do have a symbol for median. It is MD or MED. You do have a choice. You're supposed to use a symbol if the book provides one, or the text, or the calculator. Okay, so that would be our symbol here. This is the one. MD is from the text, and this is the one from your calculator. And then that one we should find on the screen if we just tap down. 1, 2, 3. See? It's 41. Okay. So find the mean, find the median, find the mode. Excuse me. Okay, so excuse me. The mode is remember with the mode, I have data value and number of occurrences. Okay. And I'm going to sort the data. I already have the data in there. So I'm going to go to stat. And I'm going to go to number 2. And you have a choice. You can sort it ascending or descending. I think what we did in class, and you can do either or. I'm going to go to D because I believe I was using D for that. And then second L1. Okay, and then hit enter. And then go back to stat, edit. Okay, so 1008 appears once. So if they only appear once, I'm not going to write them down. See, this appears once, 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 one time. All these are appearing just one time, so there's not a need for me to write them down. Okay, so it looks like 58 appeared twice. Okay, here 6 is coming up. Let's see, 1, 2, 3 times. Okay, 6 is appearing 3 times. Okay, looks like 2 appeared 5 times, right? 1, 2, 3, 4, 5. So 2 appeared 5 times. And then 1. That's 1, 2, 3, 3 times. Okay, so it looks like does that look like all the occurrences? Let's see. Okay, good. All right. Okay, so then we're looking for the mode, the one that occurs the most often. Well, it looks like it's going to be data value 2. Most often. Yeah, so it looks like your mode is 2. Okay, 2 appears the most often 5 times. Okay, what is it they want us to find? Find the mean, the median, the mode, oh, and the mid-range. MR mid-range. So low plus high, right? Basically divided by 2, right? That was the idea. So you know your lowest data value is 1. And I forgot what the highest one was. Let me go back up to the top. Okay, looks like the top, looks like it was 1,008. That's like 1,009 divided by 2. Okay, so now let me do that. So I'm just go to second quit. See, I have all this here. Let's go to second quit. Okay. So I'm going to make a note of that. So I'm just let's put it here. Second quit. And it took me to this screen here. So I do open parenthesis 1 plus 1,008 close parenthesis divided by 2. Looks like I get 504.5. 504.5 for the MR. All right. Okay, so then now that we found all that, okay, now to answer those questions, now we're going to determine the data's distribution. What is this data's distribution? So it means like is it right tailed? Is it left tailed? Is it symmetric? So you kind of like think of here your think of your x-axis and we have the 3 M's. So what was the small, and we're not using the mid-range. Remember this paper? You remember you want to see page 67 from your workbook. So remember this paper? See, you want to look at your mode, median, and the 3 M's. the three M's. Just don't look at the MR, look at the other one. So the smallest, and I highlighted them. Let me see. So the smallest is 2, and that's the mode. And then it's 41, and that's the median. And then the biggest was 134.7, and that was the mean. Mode, median, and mean. Mode, median, and mean. See how that matches? It can't be these. They're not all the same. They're all different. And it can't be this one. Here it's mean, median, and mode. So the median's always in the middle, but it says mean. We're starting off with mode. So it's this one. Mode, median, and mean. So this is positively skewed. Right skewed. So what's the status distribution? Data distribution is positively skewed, which is right skewed. Okay. Okay. So, and I think I had one last page just to show you still on that topic. This is something I pulled off the internet, just a really good picture of that. It says the same thing. Skewed distributions and mean, median, and mode measures of central tendency. Okay, so I got this off of the YouTube, I guess. Yeah, but you see here, see how they have mode, median, mean, which is what we had, right? It was mode, median, and mean. See that? Positive skewed, right skewed. Then this one, mean, median, mode, negatively skewed. They have it's the same. They agree. So this is out there on the discuss the relationship between the mean, medium, and mode, and that's what this is doing. Okay. All right. Okay. So I'm gonna that'll wrap up our section. I'm done with our section. Okay. So thank you. I'm gonna close this out.